Hi everyone, welcome in computer vision session. So what is a computer vision? How the computer vision will be help in the real world, and with the computer vision what we can develop using the artificial intelligence we will see in these sessions. So first of all, computer vision is a uh, is a field of artificial intelligence. Okay, so where we can use the computer vision. So computer, some examples I'm giving here for the computer vision when used in handwriting recognition, autonomous driving, surveillance, and the gesture detection. This is some examples. You can use computer vision in more fields. So, what is a computer vision? Computer vision is the ability of computers to identify objects, scenes, and activities in images. So, computer vision is used in various applications, including image recognition, object detection, facial recognition, and medical image analysis and augmented reality. So this is because the computer vision will be basically work like a human vision. So what is a human vision and what is a computer vision, we will see in this coming slides. So this is example of the computer vision. This is for the object detection. So you can see here this object detection model will be predict the what is about the all the objects like dog, persons, car, traffic light, person, traffic light, then this is a sign, this is a car. So everything they will be predicting. So how the computer vision work and what is a human vision? So human vision is a biological process that involves the eyes, optic nerves, and brain working together to interpret to visuals. So human vision is incredibly complex and capable to recognize the patterns, color, shapes, texture, and depth of the speed and accuracy. But the computer vision is a field of artificial intelligence that aims to replicate the ability of human vision using the algorithms, cameras, and the sensors. The computer vision relies on the mathematical algorithm to process and analyze visual data, extracting the features and the pattern and for interpretation. So basically, image recognition is the one of the part we can say. So image pattern recognition of on features extractions we are doing, and manual feature engineering we are doing in the image recognition. And how we can do with this image? So it detecting the corners, diagonal lines, oriented edges, and the shapes, and it can be difficult to identify and complicated objects. There are the endless and combine the features and the classification techniques like including the template matching, and some models we can use the SVM, render forest, and the others. So one of the ImageNet will be help in the this self-driving cars, medical images, medical examine, and the robotics. So ImageNet is will be help to prove that deep learning work well for computer vision. So ImageNet has made a transfer learning and powerful technique. ImageNet has over 14 million labeled image across 21,000 categories. So you can use the ImageNet. ImageNet is work very good. And what is a CNN? So CNN is a convolutional neural network, and the CNN will be is a type of artificial intelligence model and inspired by human brain and process the visual information. It's particularly good at tasks like image recognition and the classification. So some like conv- convolutional neural network is learn to detect the features in the input data like edge and textures, and by applying the filters and over input images. So deep neural network designed for processing grid like a data like image and videos, and CNN have the excellent the image classification, object detection, and vision task. So the CNN model and become a very good for recognition and classification for the patterns and in images. So how the CNN will be work? So CNN components is like input layer, convolution layer, pooling and fully connected layers, and the output. So convolution layer and activation functions we are using here, the pooling layers, fully connected layers, and the output layer. So this is how it will work. So let's suppose the input will become, and it will be go to the convolution layer. After that they're going to pooling. So we will see what is a pooling and what is the how the pooling will be work. So if you can say the simple in the pooling means in simple terms is a way to reduce the size of the data. So let's suppose I have the big size of the data, so they will be reduce the size uh, of data or features maps to neural network by summarizing them. It helps to make the networks more manageable and reduce the computation of the important features. And after that, fully connected. So how will be fully connected layer, and that will be go to output layer. In the between we have a backward propagation, so that is also work. And next is what is activation function. So we have some activation function, you can see here we have some activation function after that convolution layer. So how the activation function will be work in the neural network. So we have the activation function is seen in like a gatekeeper and decide whether a neuron in network should activate or not based on the input it relieves. So it adds on nonlinearity to the network and allowing it to represent a complex pattern in the data. One common activation function is used in the CNN is ReLU. So that is a rectified linear unit, which simply turns off the input of negative and lets output value pass through unchanged. So this is all the activation function, that is ReLU function. So activation function that will be help. So this is all the activation functions. Next is pooling. So pooling is very important feature in the CNN. So pooling is a fundamentally operation for convolution neural network, is used to primary dimensionality reduction, feature selection, and translation invariance. It helped to reduce a spatial dimension like width and the height of the input volume, and while preserving the most important information. So two types of pooling we have: max pooling and average pooling. So max pooling is used for capturing the most important feature while discarding the less relevant details and reducing the computational complexity and preventing the outfitting. And the average pooling is basically used for the max pooling, and but can be beneficial for certain scenarios. Basically we are using the only the max pooling in many times. So back propagation, so this is very important in CNN. So backward propagation is basically we can say back uh, so back propagation. So back propagation in the short words we can say backward propagation of the errors. So we have our input layer, we have the hidden layer, we have the output layer, and we have the backward output layer. So how it will work? So let's suppose you're giving the input and it's going to hidden layer. Okay, so and the processing is going on, then after that processing it's going to output layer. But the backward propagation, it will be give you back of that things, and after the backward propagation you will be receive that output again in the neural network. So this is how it will be work. It's improve the network ability and extract the features, make accurate predictions, because it's going to back to the input layer, output layer. So it will be go back. So overall the back propagation is backbone of training a neural network, including CNN, enabling them the data and improve their performance on various tasks such as image classification, object detection, and the segmentation. So we will see the handwriting project. So how the handwriting project will be work in the using the computer vision in the next sessions. Thank you guys.